My name is Tim, and I've been working in the iOS community since 2008, since the very beginning, and organizing events. And I've seen a lot of people come to Objective-C, and I've seen many of them complain about it. I've called this talk Interpreting Objective-C because I hope it helps you understand Objective-C a little better and helps you realize that when people talk about Objective-C in terms of brackets and semicolons, they're missing something very important. They're really the true nature of the language and the platform that we have. So first, I want to get this out of the way, which is a joke that my physics teacher in high school told just relentlessly. What's new? And who knows the answer to that? What's new?
A letter.
C over lambda. So new is frequency, c is the speed of light, lambda is wavelength. So that's the physics joke. So go tell your friends what's new. The answer is c over lambda. So I want to talk in terms of what I'm going to call the cycle of creativity in software, the cycle of creation. And we all start at the upper left in the usage quadrant, or in that section. And that's really most of our careers. We spend our time building things using technologies that already exist. Usually they're things that other people have made and they've trained us how to use them. I spent a lot of my time in that space working on electronic design automation tools. These were CAD tools used to design microprocessors and other electronic circuits, big chips with millions or tens of millions of transistors, hundreds of millions that would run at gigahertz, and lots of data. And they were also very complex systems that had to be changed a lot. They had to be very adaptive. So in the process of usage, often we start to develop some desires for things to be different and desires to do better. So I want to start with desire in the story of what will unfold about new. And desire, again, it's really just to make something better, to do things better. And that's all based on a set of beliefs. So I'm going to tell you my beliefs about better first. I'll just quickly run through these. And I'm sure these are things that we could debate. But I'm not here to defend these statements. I'm just going to make them because they explain the context of what follows. So first, in any resource-constrained environment, performance is everything. All environments of value are resource-constrained. Performance is device performance and developer performance. The number of developers required to make a system is its biggest weakness. Stability and productivity are developers' top two priorities in that order. And now a two-part cone on simplicity. Simplicity allows speed, and speed increases opportunity. And simplicity allows control, and control reduces risk. Two things that we all want. And then finally, looking historically, the C platform has consistently offered the best runtime, power, and capability performance for developers. The best libraries, the fastest compiled code, and the best power consumption in our mobile devices. It's all accessed through C. There's really no other platform that even comes close to the C platform in high performance for devices. Now, for developer performance, I claim that Lisp-style languages have offered the greatest capabilities of abstraction, and that's what we want for performance as developers. So my job, I think, is to create abstractions, and I want to have the most powerful tools for abstraction that I can get. So now, after having desires, it's not really enough. You need some insight to take you forward. And the insight that I'll describe tonight is this. Objective-C, more than just a collection of brackets and semicolons, is a platform that solves many of the key problems in bridging C with high-level languages like Lisps. First, it's introspectable. So because of all the information that's in the Objective-C runtime, I don't need any glue code to bind my high-level language to compiled objects. This was really the intent of the language. Brad Cox, the person who invented Objective-C with Tom Love, used to talk about software integrated circuits as a metaphor for what we would make with Objective-C. And these are things that you could pull apart, test independently, and put back together with dynamic binding technologies, which is the dynamic message sending technology that we have in Objective-C. So it's introspectable. In contrast, if I were to take some compiled technology, some compiled code, and publish it for developers of some high-level language like Python, if I wasn't using the Objective-C runtime, I'd have to create a bunch of code that bridged the C code with Python and converted the C calls. It would convert the calls from Python into calls to the appropriate C objects. And I'd have this layer of really ugly, yucky glue code to manage. And every time I wanted to add a new function for the Python side of the wall to use, of the group to use, I'd have to rewrite this glue code and add things to it. I don't have to do that with Objective-C. And then a second thing about Objective-C that's interesting and very appealing is that it's so dynamic. This runtime that gives us a directory of our classes and the methods we can send to them is open to us. So while our programs run, we can add things to this. So we can, while a program is running, you all probably know this, create new classes and add new methods to those classes and to existing classes. So now the question of what's new. The second answer is this. New is an interpreted dialect of Lisp that parses into Objective-C objects that can be evaluated to perform computations. I'll show you a picture that illustrates that in a little bit. And then second, new interacts directly with the Objective-C runtime to create and use classes, methods, and objects. So what new isn't is a separate language that's bridged to Objective-C. New is really, it's like a dialect of Objective-C, or a structured way of creating data that turns into objects that are just like the Objective-C objects that you write in your Objective-C code and compile with Clang. Makes those objects, they can interact with those objects and with new-based objects in a way that's unobservable. I mean, you can't tell the difference between the two. So let's talk about the craft of new. So once we've got this desire and this insight, now we have to make it and make it work. So the first thing to look at is parsing new. I said that new parses into a set of objects. So here's a very simple S expression. It's a parenthesized expression. There's two expressions there in parentheses. This is the standard new Lisp-like thing that you closure people see. It's like the most primitive syntax that you can have. And in it, I'm saying, this is derived from Ruby. The put statement is going to print something, and it's going to print the result of this addition. So plus, we're going to add 2 plus 2 and print the result. So this is a list, and this is a list that contains that list. So classically in Lisp terminology, the components of lists are cells. So you have a set of cells that are linked together, and historically, the left side of the cell is called the car, and the right side is called the cdr. This has to do with the machine architecture of the original machines where people wrote Lisp. That's in the code of new. But for now, I'll just say these are objects of a certain class. The class is new cell. So I defined a class in Objective-C, and that class represents the links in these linked lists that the code is parsed into. And so you can see, kind of going inside out, plus 2, 2. Each of these cells points to the next cell in the list, and then the front part of the cell points to the object that's in the list. And so there's an operator, an NS number, and an NS number. The operator is it's an instance of a type that's defined in the new code, and that knows how to add numbers. And then this sub-expression is the second element in this list that begins with puts. So all of the new code that gets parsed into structures like this. This is all like familiar Objective-C stuff. New cells implement NS coding. So I can just archive the whole thing. I can, you parse code, and you can use keyed archivers to write the whole thing out to data. You can send it over a network. You can put it in a database. You can do all kinds of interesting and fun things with that. You can modify it too, because you can just unhook these things. I don't do too much of that, but I do all the other things that I've said. So now, evaluating new. A lot of people have said, well, where's the interpreter in new? There actually is no interpreter in new. These objects all have a method on them called evaluate with context. And so to evaluate a new expression, we just send the evaluate with context message to the head of the list. And so what we're doing is sending a dictionary that contains variable assignments to this thing and saying evaluate yourself. These variable assignments, things like closures and other like variable hierarchies, we can handle that by having dictionaries point to dictionaries pointing to dictionaries. And then there's a global symbol table where you can make global assignments of values. But this is the state of the program. So it's a mutable dictionary because we're going to want to be able to add variable assignments to that as things run. So when the puts operator, so first the cell gets sent this evaluate message, and it relays it to the puts operator. And the puts operator says, well, I need to evaluate my arguments before I print them. So it asks this to evaluate, and this asks the add operator to evaluate itself. And it does that by first evaluating its arguments. Numbers evaluate to themselves, so we pop back up, we get 4, and we print 4. So that's the process of evaluation. And if you manage your global symbol table carefully, you can run these in multiple threads. So there's no like interpreter lock. You can keep your dictionary separate. You can evaluate new on as many threads in parallel as you like. So parsed S expressions correspond to two kinds of things. First, let's talk about operators. These are things that are followed by arguments, and when you evaluate this expression, that operator is in charge. You basically send that operator a message saying evaluate, and whatever the operator does depends on how it's coded, and in this case it divides and then it adds and we get 4. Then there's another thing which is wrapped in parentheses, and that's a message that we're sending to an object. So in this case, UI storyboard is an object that represents that class, and we're sending a message called storyboard with name bundle and passing these two arguments, name and nil, to that. And so you see the appeal of S expressions to me. I can so beautifully write these message sends that are so awkward and kludgy in other languages that are bridged to Objective-C. If you look at how PyObc does it, or even what Ruby, Mac Ruby does now, it's kind of awkward because they use another basic dictionary to put this together. And here we have kind of the purest, cleanest mapping of Objective-C messages into some higher level syntax. So these things interact with the runtime. If I have a class UI view, that's a symbol. So when this evaluates, that symbol may not be known while the program is executing. So I look in the context, I don't find UI view's value. I look in the symbol table, and maybe it's not in the symbol table yet. Well, it is because it's been parsed, but it doesn't have a value. So within new, there's kind of a hierarchy of resolution. And if something's not known, one of the things that we do is look in the Objective-C runtime for a class with that name. So we automatically look up the class, and we find there is a UI view class. And then alloc is used to get a message. So we look up that message, and we send that message to UI view. And then we send an it with frame to the result of that, to the view that we've alloced. And that requires a frame, a CG-rect, to be passed. And you see here, this is notation for a list. So I've got a quote, which basically tells Lisps to not evaluate what's inside this, just take it directly. And that's a list, that's not a CG-rect. But we can look in the Objective-C runtime and find what this wants, and find that init with frame expects a CG-rect as its argument, and automatically convert that list into a CG-rect and send the message. So that all happens because of the runtime. It's like magic. There's no glue code. So you can just write a new class with some messages and immediately call it from new. And as I said, the Objective-C runtime is open, so we can write, there is a class operator in new that lets us define a new class, and we can say what it is. It's an instance of NSObject, and we can add both class and instance messages or methods to it. In this case, I added a method that takes no arguments, and it does puts, hello, and we've got a new class with a new instance. And you can open the new shell, and you can, this is part of the new distribution, you can run this at the command line, and you can type this in. You can make an object that's an instance of your new class, and send hello, and it puts hello. So you can take that and run with that. So now I want to just briefly, very briefly, talk about some things that I've done with this and that other people are, different things that have been done with new. So the first thing that you can do, which is really easy, is generate p-lists. And I don't know how you generate p-lists, but I tend to use p-lists a lot to represent things inside my apps. And I'm kind of hooked on having an easy way to generate p-lists. If I didn't, I might not use p-lists so much. So what I have here is I'm setting a variable named me to a dictionary that I create with this dict operator, and it takes a list of things that are in pairs. There's a label, and then some value. So here I have a label, and then a string, a label and a string, a label, and then another dictionary with some things in it, and then I have a label in an array that has some dictionaries. And that builds for me a nested dictionary with a bunch of other stuff in it that I can then send a message, which I've added in the new source code, that lets me send this XML property list representation, and it basically calls the NS property list serialization code to generate the NS data for that plist. And then I just write that to a file, and I put that on there because that's what the NS data write to a file thing does. Ask me if I want to do it atomically or not. And then I have a plist, and this you're not going to be able to see, but you could see these slides later. This is the plist that gets created for that. And I think that is much easier to edit and manage than that. And one of the things I didn't tell you about this is that formatting is all done automatically. So I use TextMate. I have a code formatter that's automatically used inside that. I mean, I just hit a key and it formats, and so it's all managed. Now, a couple of other things. I'm short on time, so I'm just going to flash these up. This calls the remote API. So here I'm calling the Google geocoding API. I load a couple of Objective-C frameworks that I've written with helpers, and then I build a dictionary that's the parameters that I'm going to pass to this API. I construct the request, and then I just use NSString, string with contents of URL, with the URL that I get from URL with string path. And I get a dictionary, or I get data back, and then I ask for its JSON value. I get a string back, and I ask for its JSON value, and I put that. And I get a big thing because of what's returned by the geocoding API, but it includes this, which is the coordinates of the address that I sent. So how do you call APIs? This is how I do it, and it's easy to script. I could write a loop that reads a bunch of things out of a CSV or some database and does all this geocoding, and I can just suck all the geocoding from Google that I need with that. You can also write unit tests. One of the early things that I needed was a way to make sure that new still worked when I added things. So there's a little test framework. I have a class that's in, when you create a subclass of new test case and you add methods that start with the word test, you get tests. They get run with a test program, and you can run them with this new test utility that runs the test and tells you how you did. So you can do this with any framework also. So if you write an Objective-C framework, a lot of times you'll write something and there's not really anything in it that says it's iOS specific. It's a framework that you could run on either iOS or the Mac. Maybe you're building like a full-text search index, or just some structure, or an R tree for doing geo searches. You might write that in C and wrap it in Objective-C and put it in an iOS app, but it's nice to test it on the Mac. And you might find there's other stuff you want to do to prepare data that would make you want to run that from the Mac. So you can build it as a framework and run it with new. I've got new in some iOS apps. There's the Renaissance conference app that has new in it. This app is highly plist driven. Every screen is determined by a plist, and the plists are generated by new code that runs in the app. And then finally, I've got some websites that run with new. So I don't know if you've ever used OpenRadar, but the original OpenRadar I wrote in 2008 using Google App Engine, and Google gradually starts turning up the temperature on the stove and makes it more and more expensive. So I've been writing a new version that I just previewed over the weekend of OpenRadar, and that's written in new. So every HTTP request gets turned into a get. This is a macro that it says get radar ID with a colon at the end, and that just matches a number. And then this looks up the stuff in the database for the radar and builds HTML and shows it. And on the programming.new website, front page has describes some things I added to the language to make it easy to generate markup. So HTML is a pain to manage because you have to balance tags. And you want to generate it from code. And people say, well, you can use templates for that, but you still have to balance the tags in your templates. I would much rather just use an S expression for that because I'm already in the discipline of keeping my S expressions balanced. And so why do I need an end tag? I just have an operator that says, this is going to be an H1, so whatever's the argument to that gets wrapped in H1 tags. So that's that. That's new. You can get it at programming.new. You can get the code. It's Apache 2 licensed at my GitHub account, github.com/timburks/new. And it runs anywhere Objective-C is run. And that's not just all the Apple devices on the left, it's also Linux on the right. So I'm running OpenRadar and the Renaissance Conference website on Ubuntu with GNU-step. And actually the latest version, there is an Objective-C runtime on GNU-step that supports Arc and all the new stuff in Objective-C. So GNU got dramatically simpler a couple years ago when the Objective-C runtime got upgraded. And at that point, I dropped support for Linux, which I put in the first year. But I dropped that, and then I came back to Linux after the Objective-C runtime on Linux caught up. So that's new. And there are languages whose developers say they come with batteries included because they're so proud of all the libraries that come with those languages. But by now that the way they get those languages is by enlisting hordes of people to write wrappers for various things that you then hope will work when you rely on them. And what you find is that glue code is some of the flakiest, most unreliable stuff ever because it's usually hobby code. It's usually somebody says, well, I'm going to write something for fun, so I'll write a wrapper for this satisfiability solver so that can be used in Ruby. And I did that a long time ago. And I abandoned it, and then a couple years, like last year, someone wrote me and said, what is this thing that you wrote for this Ruby wrapper for this satisfiability library? And I said, I don't want anything to do with that code anymore. So batteries, this is way better than batteries. This is like having nuclear power because there is no glue code required to use really any of this stuff on here. So all the stuff on the left is stuff that Apple just gives us built into framework, the foundation framework. And so there's file handle, NS value, sets, NS process info for getting the arguments to a process. You go around NS XML document, PDF kit, NS XPC connection, so you can talk to XPC processes. And then there's a bunch of things that third parties like us have written that you can also access from GNU because they're written in Objective-C. So like CocoYAML or FMDB or CorePlot. And then finally, there are a lot of things written in C that are just trivially easy to wrap in Objective-C and call from GNU. So you take these things like MongoDB or Postgres, and they have really nice C APIs for remotely accessing these databases. And you look at it, and typically you create a connection thing. You create this token for your connection, this value, and then you do things with it. So what do? You wrap that in an Objective-C class, and you send messages to it. And then you can use it in your Objective-C app, and you can call it from GNU. So I am having a lot of fun with this, and I hope you try it and do too. So that's it for me. Maybe they'll let me take questions, but I can't see you. Yes?
It appears that the first thing in an S expression is not always a function.
That's right, it's in an object sometimes.
So, but the interpreter takes care of that by,
Well, so I added a method to, so operators take eval with context. So does NSObject. So NSObject takes eval with context, and then it's kind of subclassed down, and something figures out what's the right thing to do. The evaluate with context on NSObject tries to treat that S expression as a message being sent to that object.
got it.
Okay.
We got another question in the back.
Okay.
I was wondering, what kinds of things do you find where new really helps you be more productive than you feel like you would be writing in direct Objective-C? If you're writing in Objective-C, maybe the syntax is more awkward, maybe there's other things that are more static. You have Xcode helping you complete some whatnot.
Yeah.
Whereas new, maybe other things are more powerful. So I'm wondering, what are the particular kinds of tasks where you feel like this really shines?
So where it really shines, really rocks, is when there's a higher level language that I need to solve some problem. And the web is a great example of that. Building HTML pages. How would you do that in Objective-C? So I guarantee you whatever you do would be much more verbose and tedious than what I do. And then inside my iOS apps, I have actually built a full iOS app, not published, but just as an exercise in new, so that I could see if it's possible. And there are only a few things that are hard to do with new. These involve calling C functions directly. There are ways to do it, but I've actually stopped supporting that because I don't really care. So what I use new for is to build abstractions within my code. And in the case of the Renaissance Conference app, there's one really smart view controller that takes a plist that determines what it draws. And then there's new code that generates that plist. So that's the code that I have, that I need a lot of that. I need that for every screen in the app. And that's a lot easier to write in new than in Objective-C or, God forbid, a nib file. So.
All right.
Okay.
Thanks a lot, Tim.